Okay, here's a quick tutorial on how to make a histogram. So in our data management course, we display data using lots of different types of graphs, such as bar graphs, histograms, pictographs, box and whisker plots, and lots of other ones. But this tutorial mainly focuses on how to display data using a histogram. Okay, so before I teach you how to effectively make a histogram to display your data, you need to understand what a histogram is and when to choose to use a histogram over other types of graphical representations of data, such as bar graphs. So first of all, what is a histogram? A histogram is a frequency distribution where the horizontal axis is divided into equal class intervals. So that's an important point there. The x-axis is divided into intervals, into which the data is then divided into. The heights of the rectangle, so on the y-axis represents the frequencies associated with the corresponding intervals. And it's important that each interval has the same width. That's important, okay? And histograms, when do we use a histogram? We use histograms for continuous data. So I'm going to explain to you a little more in depth what continuous data is. It'll probably help if I show you a little diagram of what I'm talking about here and compare it to a bar graph, which everyone is familiar with, okay? So a bar graph, we know on a bar graph, we've got our independent variable on the bottom. I'm just going to call it 1, 2, 3 for now, and with each point on the x-axis, we have a bar that tells you the frequency associated with that value. So how many ones do you have? So let's say on the y-axis, my frequency 1, 2, 3, 4, and so on. This would tell you have 2 ones. If I drew a bar for the 2, this would tell you have 3 2s, and you have 4 3s, and so on. The height of the bar tells you how many you have of each of those. And notice there are spaces between each of the bars. Why are there spaces between the bars? Well, because bar graphs are used for discrete variables. They're used to display discrete variables. What's a discrete variable? It's a variable that can be measured using only whole number values. Okay, so only integers. So whole numbers. Basically, no decimals are possible when measuring the variable. Okay, so why is there a space between the bars? Well, because there's no possibility that there could be anything between 1 and 2. The value of 1.5 is not possible in this case. The value of 1.375 is not possible. All we have to worry about is how many 1s do you have, how many 2s do you have, and so on. Let me give you an example of a type of discrete variable. Maybe that'll help you understand it a bit better as well. So if I want to figure out, okay, how many goals did I score in hockey last year? Okay, I could have had 40 goals, I could have had 41 goals, I could have had 42 goals, okay? But I couldn't have had 40.35 goals. Decimal values are not possible measuring that type of variable. Easy way to tell, if you're doing a count of a quantity, so if you're doing a count, like how many questions did you get correct on the last test, okay? Or how many goals did you score, stuff like that. That's going to be a discrete variable because you're doing a count of a quantity. So you're going to display that data using a bar graph because it's a discrete variable. Histograms, on the other hand, okay, the x-axis is divided into intervals. So my first interval, let's say I have from 0 to 5. My next interval is from 5 to 10, next 10 to 15, 15 to 20, and you get the point. The y-axis is still my frequency. So the y-axis is the frequency, just like on the bar graph. Let's say it goes up by ones as well. Now, the way I draw my bars is going to be a little bit different. So the first bar is going to tell you how many data points are between 0 and 5. So let's say I have 2 data points between 0 and 5. I would draw a bar that covers that interval that goes up to a height of 2. Now let's say I had 3 data points between 5 and 10. I would draw a bar that has a height of 3 that covers the interval from 5 to 10. Once I have 4 data points between 10 and 15, you draw a bar with a height of 4 that covers the interval of 10 to 15. Okay? And notice each of the bars are touching. The bars are touching. There are no spaces between the bars. Why are there no spaces? Well, because there could be data anywhere. I could have a data value of 5.493. That's fine. That piece of data would go into this interval. Okay? So the type of variables we use histograms to display the data of are continuous variables. Continuous variables are variables that can be measured using any real number. Real numbers, basically, they include integer values as well as rational numbers and irrational numbers as well. So we could have decimals. Decimals are possible when measuring these variables. Whenever you're doing the measure of the quantity of a variable, so anytime you're doing a measure, as in the speed of something, or the height of something, or the weight of something. When you're doing a measure like that, you're going to get a continuous variable. If I want to know the height of someone, they could be 182.45 centimeters tall. That's very possible. Okay, so that would be a continuous variable, and we would use a histogram to display that data. Okay, I think I've talked about everything I needed to there. So histograms used for continuous data. I gave you some examples of continuous data, and we talked about, okay, when you're doing the measure of a quantity of a variable, okay, that's usually going to be a continuous variable. If you're doing a count of the quantity of a variable, that is going to be a discrete variable. Okay, now let's actually make a histogram. Before we make it, I just want to lay out with you all the steps we're going to be going through in order to make the histogram. I'm not going to read through each of the steps because I'm going to be referencing them as we go through doing our example, but if you want to pause the video and read them through now so that you can have a head start, that's fine. So basically, I want to make a histogram for this data. Why do I want to make a histogram? Well, because this data represents the heights of 2 high school classes. So I've got all the heights of the students in 2 high school classes recorded below here. I want to display it using a graph. To figure out what graph I want to use, well, the variable is heights. Height, decimal values are possible when measuring the height of a person. So that's a continuous variable, which means I want to use a histogram to display this data. Okay? You might be saying, well, these are whole number values. Well, yes, I made them whole number values so that our first example is easy to do, make it as simple as possible for the first time I make a histogram. But the point is, height itself is a continuous variable, because when you measure the height of someone, a decimal value is possible. Okay, so now I want to, before I can make my histogram, I know I'm going to have to divide it up into intervals. In order to do that properly, we're going to first have to put the data in order. So I've done that for you below here. All of the data is now in order, starting with the smallest value, ending with the highest value, and in order in between. Now I need to figure out, the tricky part of histogram is figuring out how to make the intervals on your x-axis that your data is going to be put into. Okay, there's a very specific way we have to do that. To start off with, let's figure, okay, what range of data do I need my intervals to cover? So I need my intervals to cover the data between 120 and 193. So I need to figure out the range of my data. To figure out the range of your data, you just take your highest data point, 193, and subtract your lowest data point, which was 120. So I need my intervals to cover a range of 73. So I need to figure out, okay, how big should my intervals be in order so that it covers a range of 73, and the question tells us we want 8 intervals. The question will always tell you how many intervals you should have, and it'll always be somewhere between 5 and 10 intervals. That makes the graph easy to read. Okay, so if I wanted to have 8 intervals, I need it to cover a range of 73. How big should the intervals be? Well, there's a formula for that. When I'm talking about how big the intervals should be, that's called the bin width. So I'll write that here, bin width. And what we could do, we just have to take our range and divide it by the number of intervals we want. We want 8 intervals, okay? So I had to take my range and divide it by 8, and that'll tell me how big the intervals need to be so that it'll cover exactly the range from 120 to 93, okay? So I could do 73 divided by 8, and that'll give me a value of 9.125. So that means that's not a really nice number to make your intervals go up by. It's not going to look nice on your graph. It's going to be confusing to kind of read. For example, your intervals would be, so my lowest value is 120, so it would start at 120, and then my first interval would be from 120 to 129.125, and the next interval would be from 129.125 and add 9.125 to that, and I'd get 138.25. So your intervals, they're going up by not a very nice number. It makes your graph kind of cluttered, not very easy to read. So what we want to do, instead of doing that, let's not do that. Instead of doing 73 divided by 8, that 73 is the minimum range I need my intervals to cover. I'm going to round my range up so that when I divide it by 8, I get a nice whole number. So what you need to do, you need to figure out what can I round 73 up to so that 8 divides evenly into it. And the answer is I can round it up to 80. 80 divided by 8 is 10. So if I have my bin width be 10 and I have 8 intervals, okay, that'll cover a range of 80. I mean, that's more than I need it to cover. I only need it to cover 73. but that's okay. At least it'll cover all of my data, and it'll go up by nice even numbers that'll be displayed nicely on my graph. Okay? You might be saying, okay, well, why do we have to round the range up? Why round the range up? Why not round the range down to 72? 72 is closer to 73 than 80 is. Why not round it down to 72? Because 72 divided by 8 also gives me a whole number. It gives me 9. Well, if you think about that, if I have 8 intervals, each with a width of 9, it's only going to cover a range of 72. So it would only cover a range from 120 to 192. So where would we put the data value 193? Where would it go? It wouldn't have anywhere to go. So we can never round our range down. You always have to round your range up so that all of your data points fit inside one of your intervals. So I rounded it up to 10, so it's now going to cover a range of 10. Okay? So it's going to cover a range, it's going to cover a range of 80. I rounded my range up to 80. They're going to have a width of 10. It's now going to cover a range of 80. So it's going to go from 120 all the way up to 200. Now, there's a little bit of a problem with this. You'll notice our range starts exactly where we need it to. It starts right at 120. But it finishes 7 higher than we need it to. So our last interval, there's a lot of excess in that last interval where I know there is no data. So my last interval is going to have a very small frequency because not lots of data is going to be there. So it's going to kind of skew the graphical representation of our data. So what we need to do is we need to take care of that, that excess that we have. And since we rounded this up, we rounded it up by 7. We rounded it up by 7. So I've got 7 extra range that I know none of my data is going to fall in. So I need to distribute that evenly above and below my lowest and highest data points, so that it doesn't skew my graphical representation too much. Okay. So what I'm going to do, I'll show you what I'm going to do. Since we added 7 to our range of 73 and we rounded our range, we should subtract half of that excess range, half of that 7, which is 3.5, from our smallest value. Our smallest value is 120, which makes our starting point, instead of starting right at 120, we're going to start at 116.5. Okay? So I'm going to start at 116.5 and go up by 20s. Another way to calculate that value of your starting point of 116.5 is essentially what we just did, is using this formula here. Take your lowest value and then subtract half of the difference between your rounded range and your actual range. So the difference between my rounded range and my actual range was 80 minus 73, which was 7. Half of that is 3.5, so subtract 3.5 from 120, we get 116.5. So if you want, just use that formula and you'll get to the same point that we got to there. Okay? Now, the next thing you need to do, you need to make your frequency table. So I've done that for you here. We decided that our initial starting point is going to be 116.5, and we also decided that we're going to go up by 10s, and that'll cover a range of 80. Okay? So that means we'd start at 116.5. It's going to cover a range of 80, so it's going to go to 186.5. That's what our range is going to cover. You'll notice it starts 3.5 lower than we have to. Okay? Oh, sorry, 196.5 is what it should say here. And it ends 3.5 higher than it has to. We only need to cover up to 193, but it goes to 196.5. So it starts 3.5 lower and goes 3.5 higher than it needs to. So we distributed that excess of 7 evenly above and below, which is what we want to do. Okay, now when you make your frequency table here, we start at 116.5. I told you why we do that, and we go up by 10. So the first one goes from 116.5 to 126.5. The next one goes from 126.5 to 136.5. Next one, 136.5 to 146.5. An important thing to note here, the number one interval ends with, the next interval starts with that same number. So this one ends with 136.5, the next one starts with 136.5. Okay? And then what you're going to do is you're going to need to count how many data points are between 116.5 and 126.5. So you would go back to your data. How many data points are between 116.5 and 126.5? Well, this one, and this one. So there are 3 data points within that interval. So you would put 3 there. If you do that for all of them, okay, then you would get your frequency distribution, and then we could then graph that. I'll show you how you could do this on your graphing calculator to get it to count the frequencies for you, if you would rather do it that way. So if on your calculator, what you have to do, input, it takes a little bit of time, but it probably is faster than counting manually the number of data points within each interval, especially if the data points aren't in order. Okay? So what you have to do is first put all the data points into your calculator, which I did already. So just go to Stat, Edit, and put all of the data points into L1. So I put all 50 of the data points into L1. What you next have to do is you have to get your calculator to display it using a histogram. So what you have to do is turn your stat plot on. So hit second, y equals, and turn the first stat plot on. So enter, turn it on, then go across to the histogram option. And now we want it to display the data we put in L1. That's good. So now if I hit graph, it'll give me a histogram. I'll have to zoom in on the data probably. Hit zoom 9. The only thing, it's not going to have the same interval boundaries that we have established. So what you need to do is you need to change them. So you need to go to Window, and the X minimum value, so we started at 116.5. X max, it was 196.5. And the scale went up by tens. Y min, we'll make it go from 0 to 10, going up by ones. And now if you hit graph, oh, it didn't. Let's make our frequency go up a little bit higher because this bar went off the screen. So window, we'll make Y max, make it be 15. There, we'll graph it there. Good, now all the bars fit on. If you want to see the frequency of each of the bars, just hit trace. So this tells you this is the interval from 116.5 to 126.5, and it says n equals 3. That means there are 3 data points in that interval. And if you hit to the right, it'll tell you the next interval. There are 3 data points. Next interval, 1, 7, 7, 9. And then if you look at our data that I counted out for you, 3, 3, 1, 7, 7, 9, same thing. Okay? So, and the graph that we have on the screen here is exactly how we would have drawn the graph manually. So make sure you do your intervals along the bottom. Make sure you put your break here, showing that this gap here is a different width than what we have our widths of our intervals along here. Okay, so put your break, and then our first interval is from 116.5 to 126.5, and then you draw your bar between them with the height corresponding to the frequency of the number of data values between 116.5 and 126.5. Okay, so that's how you make your histogram of that data. We're going to do one more example where we're going to encounter the other type of problem you could have when making a histogram. So this is the last example we're going to do. Okay. So, all right. Earthquakes are measured on a scale known as the Richter scale. There are data of a sample of earthquake magnitudes in Canada between 1960 and 1965. So here's all of the data here. Notice in the question, it tells us earthquakes are measured. So we're measuring the quantity of something that we know that's a continuous variable. So we know we're going to use a histogram to display that data. Okay? So I've got all my data. First thing you have to do is put the data in order. So I'm going to do less explanation this time and just more of actually making the histogram. So put the data in order. Next thing you have to do to figure out what you need your interval widths to be is you have to figure out what is the range of your data. So it goes from 4.6 to 7.2. Okay? I'm actually going to show you an example of a bad histogram just to show you what type of problem we could encounter with this, okay? So I'm going to show you a couple examples of what not to do before we go ahead and actually figure out our range and our bin width and all of that. Okay, so I'm going to give you an example of a histogram made to represent this data. So here's an example of a histogram to represent that data. And you'll notice that there's lots of bars that have a frequency of 0. The bars are very thin. The problem with this is the bin width is too small. When you have lots of gaps between bars, so when you have lots of bars that have a frequency of 0, that means you've chosen a bad bin width. Okay? Usually you want between 5 and 10 intervals. With this one, there's many, many more than 5 and 10 intervals, even though it only shows you the actual values of a few of them. Okay, so what we want is we want a bin width that'll give us between 5 and 10 intervals. So you might say, okay, this one looks a little bit better. I've got 1, 2, 3, 4, 5, 6. I've got 7 intervals. So that's a little bit better, a good number of intervals. But there's another key problem with this. So if we look back at our data, look at this data point right here, 5.5. Now look back at our representation here. Notice that one of the interval boundaries is 5.5. So where does that piece of data fall? Where does this piece of data fall? Is that represented by this bar or this bar? How do you know? It's ambiguous. You don't really know where it is. So that's what makes this graph kind of confusing. What you have to do, there's a little trick to make sure that your interval boundaries, to make sure that none of your data points actually fall on your interval boundaries. So we're actually going to take care of that. We're going to make a proper histogram for this data that eliminates this problem of having your bin widths too small, giving you too many bars with a frequency of 0. So we're going to take care of that, and we're also going to take care of this, where some of the data falls on the interval boundary. Okay, so first thing we have to do is we have to figure out the range. So the range of data, you do the highest value minus the lowest value, and we get a range of 2.6. We want 6 intervals, okay? And we want them to go up by a nice value. So I want to round 2.6 up to a number that 6 divides nicely into. So if I round 2.6 up to 3, that'll give me a bin width of 0.5. That's a nice bin width to go up by. When your range is so small, it doesn't necessarily have to be a whole number, but having a bin width of 0.5 is better than going up by like 0.346 or something like that. So having a bin width of 0.5 is appropriate in this case. We're going to go up by 0.5. But notice we rounded our range up. We rounded it from 2.6 to 3. So we rounded it up by 0.4. So I have an excess of 0.4. So my range, okay, instead of going from 4.6 to 7.2, it's going to go from 4.6 to 7.6. But I don't want all of that excess at the end of my, like in that last interval. So I need to distribute it evenly below. So instead of starting at 4.6, okay, I'm going to start lower. But how much lower? Well, I rounded up by 0.4, so take half of that. So I rounded up by 0.4, so take half of that, which is 0.2, and subtract that from my lowest value of 4.6 and get 4.4. Okay? However, if I do that, my intervals would be 4.4 to 4.9, because remember I'm going up by 0.5, and 4.9 to 5.4, 5.4 to 5.9, and so on. We're still going to have the problem of some of our data falling on the interval boundaries. This data point here, 5.4. It would fall on this boundary here and this one. So which interval do I put it into? That's still ambiguous. So what we have to do is we have to take care of that by adding a decimal place so that we know for sure none of our data values are going to fall on any of the interval boundaries. So instead of starting at 4.4, I need to add a decimal place to this. So I need to either subtract or add 0.05 from this. So I'm going to subtract 0.05. You can do either, doesn't matter. And you get 4.35. So my first interval would be from 4.35 to 4.85. Okay? And so on, going up by 0.5 each time. And you know there are no data values that have 2 decimal places, if we look back. So none of the data points will fall on any of our interval boundaries. So that's good. That takes care of that problem. Okay? So notice my first interval boundary was 4.35 to 4.85. The next one was 4.85 to 5.35, going up by 0.5 each time. Okay? And we've distributed our range evenly above and below, so that our representation isn't skewed too much by the fact that we rounded our range up. Next thing you would have to do is calculate all of these frequencies. You could go back and count manually how many data points are within this interval, how many are within the next interval, and so on. But that might take a while, so what I do is, once again, I'll show you quickly on the calculator. You input all of the data into your calculator, so stat, edit. I put it all into L3. I put all of the data values into L3. And you then make your histogram. So you turn your stat plot on. So second, y equals, turn your stat plot on, change it to a histogram, and then make sure it has the appropriate list. I entered it into L3, so I need to make sure I hit L3 so it knows I want the data from L3. You could then hit your graph, make sure you zoom in on the data, zoom 9, and change your bin widths to match the bin widths that you made. So window, my minimum x value is 4.35, my maximum x value is 7.35, and my scale goes up by 0.5. I'll make my y go from 0 to 15 again. Whoops. 0 to 15, and my scale go by 1. Now I can hit my graph and then trace, and it'll tell me the actual frequencies associated with each bar. So that's 1, 13, 12, 6, 5, 3, and that's exactly what I have here. Okay? Then you're going to actually make your histogram, and it'll look like just like the one on your calculator. And here's my histogram. Make sure you label your axes. On the x-axis is the magnitude of my earthquake. Y-axis is always going to be your frequency for a histogram. Make sure you put your break, and then also make sure your intervals are labeled like this. Don't label it. I see a lot of people do this. They'll label this one as, they'll just write below it 4.35 to 4.85. That's not how you should do it. It makes it look cluttered. Write it like you see here. So between 4.35 and 4.85, you get a bar with the frequency associated with how many data points are within that interval. And then the next bar is from 4.85 to 5.35. Notice no data points fall on the interval boundary, and notice all of the bars are touching like they should be in a histogram. Okay? And that's all we're going to do for today for making a histogram. You can, if you want to practice making histograms, you can go to jensenmath.ca. And you can download the worksheet that goes along with this, either from section 1.1 or 3.1.